Yeah. I think it's been a long time. Yeah. 4 or 5. Yeah. Control or yeah. ISS or something like that. Yeah. Yeah. Good to see you too. I wasn't able to make your talk, unfortunately. I really wanted to see it. Was great. Yeah. I've seen your talks before, so it was anything similar, talking about diffusions from a controls perspective. Yeah. Yeah. Yeah.
Okay, everyone, please take a seat. We will get started with our final session for the panel. Okay, perfect. Thank you so much, everybody, for attending all the fantastic talk today. I'm very excited too about what I'm learning and seeing for the research from our awesome speakers. And as we also have a very large group of people attending through the room because of limited of the room capacity. And I know it's already the end of a very intensive day, so please relax. And also we have a pretty fun and interesting session at the end with our panel discussion. And with our speakers and also a new panelist I will introduce pretty soon, we will discuss at the end of the day, after you see all this kind of exciting and awesome research works, what's the challenges and opportunities for the generative AI to foresee in the future and also to envision what we can do. So firstly, I will get through with a brief introduction about panelists. So we have seen our speakers, Professor Rene Vidal from the University of Pennsylvania, and Professor Mengdi Wang from Princeton University, and also Professor Saining Xie from the New York universities, who just gave a talk in afternoon sessions. And I will be the moderator for this panel. And beyond that, I will introduce 3 of our new panelists who will just join us. So firstly, Professor Alfred Hero, who is now the program officer in the NSF funding agency and in the science directory. And Professor Hero is also the faculty research, the professor in the University of Michigan in the X department. And also Dr. Erica Briscoe, who is the program officer from the DARPA agency. And Erica is also very nice to join us in this panel discussion on behalf of the perspective, like from funding agency, to discuss with us what's the opinion and also insights about the generative AI in the current eras. And also we have Professor Karthik Duraisamy also join us in this panel, who is the faculty and also the professor in the University of Michigan as well. And so with all the new panelists join us and also our speakers who talk about their research as well, we will start this panel to discuss the opportunity and challenges for the generative AI. And we have the time like around 45 minutes. I will try to control the timing, but it's okay if we're running out of time until 6. So that is what I just got to know from Ben. Yeah, so no worries if you have a lot of things to share or if there is a lot of questions. And then to begin with, I will just show some like the inspiring slides to give you all something to think about and specific topics under this big umbrella for the generative AI. So firstly, about from what we have seen in today's talks about how the generative AI can be so fantastic, so awesome in the different applications and also theories. But at the same time, we're also facing the limitations for generative AI models. For example, including the hallucination. So this is one video that is showing the
and then randomly disappears.
Okay,
Flaws like that can help viewers spot AI-generated videos from OpenAI.
Okay, cool.
Its new text-to-video tool, Sora, created all of these clips, from scenic landscapes to bedazzled zoo animals, without a major production studio or team of animators.
When you think about some of the most recent Pixar movies, when you think about the amount of energy that they go into to literally build every detail so that their hair moves in the right way and things, this stuff now is a computer doing without a single person.
Users will be able to type in a
So
prompt,
this
and
is
their
the
words
video.
are
It
brought
has
to
like
life,
around 7
like
minutes.
this.
So I will not
But
play
such
that
innovation
though.
has raised
But
concerns
this
about
is
the spread of
showing some
misinformation.
kind of the examples about how we are facing and also observing the hallucinations in the generative AI models.
Do you notice anything?
And beyond that, we also have seen other reliability and trustworthy issues. For example, the adversary prompts in the large language modeling. So we definitely want to keep our output or keep our model to be safe. But in some kind of case, if we have the adversary prompt that adding to the standard prompt, it may give us or output some like the unsafe or some like the negative output that shouldn't be given. So this is also something we will need to consider for the reliability and the trustworthy of the large language modeling. And also we have also seen this from our last talk from Saining about the scaling law for the LLM, which is relevant to like the computational resource and also the performance or the results. So all of this could come to some kind of the limitations we are facing at the same time with the opportunities for these generative AI models. So here is some like the simple, some like the questions we prepared to inspire this kind of the panel discussion, and definitely after all this kind of discussion, and we will come like any questions from the audience. So what do you think about, and what do you want to share, or if there is any question you want to discuss in this panel, or hear the thoughts or insights from our panelists. So we'll first start with these 3 questions, and afterwards we'll give the chance for the audience to ask the questions. Okay, so the first thing that I think will be very interesting and exciting, exactly the motivation for us to organize this symposium, is to see like observing all these opportunities, challenges, or limitations of the generative AI models in the current area. So how can we develop this model for scientific applications for a broader way, especially considering how the reliability and how the trustworthy generative model could be? There may be some concerns in the specific domains for the scientific applications. For example, in the medical domain I'm working on, people definitely want to have, like, for example, the interpretability, explainability that will be relevant to the talk that Rene gave about in the afternoon session. So just wonder, like, for the panelists sitting in the room here, so from your perspective, that could be very different in the academia, industry, or like funding agency. So what do you think is the opportunities and challenges if we're thinking about developing or advanced generative AI models for the scientific applications in general? Yeah, anyone want to?
Oh, there's a question.
Oh, yeah. Sorry. Yeah, this is not very convenient for the speaker. Sorry, for the panel. Yeah, that would be great to see the questions.
Yes.
Yeah.
I'll just take a stab here.
Yeah.
From my perspective, the generative models are really not going to yield any major impacts in the sciences or on critical infrastructure for societal benefit, unless they can handle rare events, extremal events. Most of history, human history, is punctuated by rare events. Volcanic eruptions, political unrest, fall of the Roman Empire. All these events are very difficult to predict, but there are premonitions or precursors to those events that may be modeled perhaps by a generative model. But I dare say that I believe that one of the principal bottlenecks to being able to handle rare events is the fact that most of the generative models that we've seen developed here in this day are based on a fundamentally light-tailed generative process, Brownian motion. And it's certainly one can talk about making measure transformations over Gaussian types of measures, but basically rare events are a singular measure, right?
Yeah.
So it seems to me that the technology today in in the generative AI areas are not up to the task. So let me stop there, just throwing that out.
Yeah, perfect. Yeah, that is pretty insightful. Yeah, definitely that is also the motivation we want to bring this question for the discussion. Yeah. That's our.
All right, so I'll start with, in fact, I just wrote an opinion piece in the MICD magazine on how generative AI can be used in science. So I think you can view it from the website. So I think I certainly believe, even with their current limitations, even though they are very poor at rare event predictions, even though they have very poor compositionality properties and reasoning capabilities, I still think when you have a human in the loop and the right interfaces are developed, I think they're already very, very useful, right? So I want to acknowledging the limitations you pointed out, right? So I think of these things to impact science in two ways. One is foundation models for particular domains, and then a scientific large language model type setting. And I think in both arenas, even though we've only scratched the surface, I think they're already useful, right? But I do also want to point out other kind of limitations, especially when it comes to complex systems of the type that, say, weather prediction entails, or complex systems of the type that nuclear fusion demands, or complex systems of the type that turbulence in aircraft requires. So in all of these problems, there are some peculiar characteristics that generative AI models have struggled. And one of the features of these systems is the extremely multi-scale behavior, right? So if you have something like an image, you can filter out some of these low energy features, so to speak, and you still have a cat or a mouse or whatever it is. But in many of these physical systems, those small energy features have a huge impact on the larger features that we actually care about. So it's not something that can be thrown away, and these models struggle. So that's number one, multi-scale. And number two is time, right? Static images, I think we have very good techniques, even with multi-scale thrown in. But when you have processes that evolve in time and they can become chaotic, yeah, that is currently a limitation for these methods. And then, of course, multimodality. People would say, oh, Sora is generating videos, so time is addressed in a certain way, but only it addresses a part of the picture, right? So when you have complex physical systems, small disturbances and small features can evolve in time and affect the entire system, and those kind of things are not, very prevalent in the kind of videos that you've shown. So anyway, these are some of the limitations, but I'm of the firm opinion that generative AI will transform science in unthinkable ways over the next decade, even with all of these limitations. Even if we don't address many of these limitations, I still think the impact will be high. But I do not think that they will automate science without addressing these things. With an intelligent operator, which is a human, who is much more sophisticated than all of these companies want to believe, I think with an expert in the loop, these tools will make a big impact on science in the next few years. But if many of these rare events, multi-scale, time, and if these things are addressed, then I think I cannot even predict how big the impact would be. So those are my thoughts.
Yeah, thank you, Karthik. Yeah, this is pretty insightful.
Yeah, I'll just echo some of that, but I'm fortunate in my position that our job is not only to fund basic research, but also to try to transition that to operational. So even though this is somewhat of a nascent field, we get to see, how it's actually being used in operation. And so 2 examples here, I think both opportunity and challenges. And I'm incredibly optimistic across the board, probably too much so, but opportunities in terms of really just being able to automate some of the scientific process. And so one example here is a program we have called Critical Mass, which is using AI to automate critical mineral assessment in the US, which is a huge problem. And a couple years ago, Congress mandated that the United States Geographical Survey do 50 critical mineral assessments in the next 10 years. And right now, those assessments take 2 years each. So and they didn't fund them. But so there's not enough time to do this. And so, this is a great problem for us. Like, how can we use AI to, help this? And we can across the board. It's a very complex process. It involves high level of subject matter expertise in geology and geophysics. But it's still really hard, and it's hard to get the AI to process a map, and especially a map that's really old, that's been written in a different kind of notation, and to be able to correlate that with text, for example. But we've seen recent success. We're able to turn the time to do an assessment from a year or 2 years into something like a month. So that's incredibly, the implications of being able to do that kind of assessment that quickly are very impactful. On the other hand, on another program we have where we are trying to do the scientific modeling in different application domains, epidemiology is rather, in some sense, easy when it gets to climate science, where you have these multi-level physics and these sort of models that need to interact. We see a great deal of difficulty and don't see that moving forward, at least anytime in the near term, to really affect the AI to really affect the operational use of these models. So it's a little disappointing, but it's interesting to see exactly the wall that we're hitting there, and how it's not going to be overcome anytime soon.
Cool. Thank you, Erica.
So I'm also on Erica's side, so I'm extremely optimistic about using generative AI to accelerate scientific research. So I share a little bit like this today. So for example, like I was involved in trying to design better mRNA vaccines, basically better COVID vaccines. So I thought, okay, what should we do if we want to figure out the best semantics of mRNA sequences, right? So what we do is we actually collected mRNA sequences, the sequences of ACTGs across multiple species. And we pre-trained a large language model specific for mRNA sequences. And we use it to generate new sequences with better mRNA to protein translation efficiency. And this efficiency is going to be meaning that if I have I would say a dose of mRNA vaccine, and how effective this dosage is going to depend on how much of this mRNA is going to be translated into proteins. So this translation efficiency is the most important metric here. So we were able to actually generate novel mRNA designs, and I actually worked with a wet lab collaborator who validated our designs. They synthesized my predicted library, and we were able to achieve 30% more efficiency than the SOTA COVID vaccine. And so this design was licensed, and I was really happy that language models really work, even though I cannot read those sequences. So another thing we have been doing is I didn't get time to share today is we built a large language model specifically to automate the design of gene editing experiments. So genome editing is a pretty standard practice, but it has a lot of different nuances depending on the system you use, which tissue you're editing, and do you want to do it in a small scale way or large scale way, knockout or insertion, blah, blah, blah. So it's actually a very, very useful common technology, but it's very complex. So we actually built an LLM which automates everything from the initial Q&A, selection of the system, figuring out the guide sequence, figuring out how to deliver, write experimental protocols, data analysis, and so on. So usually it would take, I would say, a PhD student maybe 1 year to really understand the field, to try out and to fail several times before the student can actually design a successful experiment. But with the tool we developed, we actually asked a new incoming PhD student to he has never done this before, to just use our tool, and he was able to achieve 90% editing efficiency at his first try. Wow. So I thought the nice thing about generative AI is we can think about either diffusion models or flow models or language models. I think the power is that they are really good at, I would say leveraging unstructured data that are already out there. to make sense out of them. It's just really difficult for a human researcher to really make an informed decision based on all the collection of unstructured data. But a potential risk is like language models, they do hallucinate, right? And actually, like, so I think a big challenge today, people are actively resolving is how to think about using those like AI for science tools in a safe way. For example, like, what if someone use, I don't know, RF diffusion to generate, I would say, a bioweapon? For example, like bioweaponism is something that's really like scary, right? Or people can try to say that, hey, I'm going to edit a human baby, right? That's definitely not something we want. So actually in our work, we actually spend a lot of time adding safety layers or adding anti-jailbreaking layers to our system. And so after our work was released, actually, so we got a lot of like invitations about this particular work, and the most common question I got to ask, I was asked was like, are you sure it's safe? So we're actually actively collaborating with the newly established US AI Safety Institute. I think this is a new initiative, and they're trying to talk to different stakeholders or scientists who are interested in this AI for biology application. And so there are a lot of discussions about like how to safeguard those models, how to make sure that such technology is only available to responsible users. And this is still ongoing, and also how to think about like anti-jailbreaking, anti-dual usage on the model level or on the agent level. So yeah, that's my 2 cents.
Cool. Thank you so much, Mengdi.
I do want to say that she brought up so many interesting points which we should discuss in the discussion session. Any other thoughts?
Yeah. Yeah, sure. If we don't need, must maybe have.
Could I just
yeah, for
have
sure.
a rejoinder a little bit here?
Yeah,
Because
absolutely.
I want to make it clarify that my position is not a naysayer of generative models. Rather, I wanted to emphasize the challenges, and I think this major challenge of trying to adapt these types of techniques so that they can be dynamic, as Karthik was just saying, and that they can account for these singularities. And singularities occur not just in terms of rare events for physical processes, but they can occur, intuition. A mathematician proving a theorem comes up with a flash of intuition. That's a singularity. How can you capture that kind of inherently perhaps logically predictable type of behavior in a generative model? I think there's lots of promise there. And in fact, we have at NSF, we have a program that is now in its second year on mathematical reasoning. So using AI for mathematical reasoning. There's a January deadline, so anybody who has some ideas in that area, feel free to
Thank you so much for sharing.
Yes.
Okay, perfect. Thank you so much for all the panelists sharing such great points. Yeah, that is totally what we want to discuss here about like the promise, challenges, and also the opportunities. And also we can see a lot of promising examples. We can also see quite a few concerns about the safety issue, all those things. So definitely there is a lot of research needed in this line. I think regarding for the time interest, we will go to another questions, what we have here in the list. And then we will have the time for answering questions for the audience. So I would maybe like to go this one because I think this is relevant to our panelists from the different perspective, like academia, industry, and the funding agency. And I think in the last talk from Saining, he also mentioned some different researches happening in the company, in the industry, and also the academia. So I think I'm really curious and wonder to, so really want to bring this question for the discussion. So firstly, for all this kind of research that we're excited about for the researcher at different organizations, different locations, different sites, how can we build such kind of the organic or collaborative community for the people or the researchers across academia, industry, funding or even funding agencies for in the supportive environment to boost this kind of the generative AI research that could be potentially to solve the issues we just mentioned in the first question, and also to broaden that to more applications, including the scientific applications. And since most people here may standing more in the position of the academia, including students, the faculty, and the researcher. So in this kind of case, this is also kind of interesting to maybe most of people in academia nowadays, how can we differentiate out research? Or I don't want to say the compete, but there is definitely some competition in the industry that's happening across different companies in the generative AI. So how can we differentiate our research from what's happening or the industry research is doing in the generative AI research? And I think the ultimate goal is definitely, I believe, only with the collaboration, we can make the greatest efforts and also the research outcomes. But in our position, how do you want to define, shape our future research, and also to have the supportive environment? Yeah, want to see panelists if you have any thoughts, insight to share.
Since I started first, I'll start again first here.
Thank you so much. I really appreciate it.
Yeah. So I think this is hard because the value propositions in terms of academic research versus industry research and development are very different.
Yes.
And that is both, a challenge and an opportunity. It's a challenge because it makes it difficult to compete just in terms of raw resources with industry, because their value proposition is basically making money. And with that kind of value proposition, they put a lot of money into resources for computing and storage and data collection and evaluation and so forth. But it's an opportunity also because the motivations are sufficiently different that in academia, we have more freedom to work on problems that may not have immediate, let me say, value in terms of the profits or revenues to the stockholders. And that's why I think AI for science is a real niche for academia. There are relatively few companies that are involved in this. Of course, there's Google, DeepMind, have IBM, have some activities that are in collaboration with academics in looking at AI for science, and but it's not their main bread and butter.
Mm-hmm.
So I think that's one thing. That collaboration, of course, is crucial. But I think that the nature of the problems that academics have the opportunity to work on are much less fettered and loaded with this desire for quick results, flashy announcements of products and so forth that industry is a lot focused on. I'm talking particularly about the infotech industry here. On the other hand, there is, I think, a real opportunity that is just beginning, I think, to be exploited in forming consortia that involve both industry and academia and government.
Mm-hmm.
And NSF is the lead agency on one such program called the NAIR, the National AI Research Initiative, Research Resource Initiative. DARPA's, I think, is also involved in that. In addition to, I would say, almost every big tech company, Facebook's and Amazon and Google and so forth, are all involved. Right now, it's in a pilot phase. There are big ideas for expanding in the future. Right now, it is open for there's an open solicitation for that indirectly will I think create an environment where there'll be more collaboration with an academic and industry but on the level of resources, right? So you can apply for resources from DOE labs, major distributed parallel computing, grid computing, from Amazon Web Services, with consulting also that's being offered by many of these entities that are participating in this initiative. So it's the beginning of an initiative which the government led, and the hope is that the grassroots will take that forward because they will perceive that there's value on all directions in this mechanism for collaboration, which is basically on the industry side just making resources available with some expertise on how to use them as consulting, and then academia is able to benefit from that in terms of having the ability to compete, at least at the level of computational and storage resources.
Yeah, definitely. Yeah. Thank you so much for sharing, Al. This is very valuable. Yeah.
Yeah, I want to echo everything that Al said. Although I don't think the clear distinction between academic research and industrial research is that clear anymore. OpenAI a few years ago was like us, right?
Yeah.
And then they changed. Anyway, so but yeah, to echo your point, so we're also trying to put together a consortium with national labs and universities and industry to look at foundation models, and by definition, it's a very large effort. So no one entity can do it. But then to more directly respond to what can academia do, right? So even if you take something like foundation models, there are so many different aspects of the life cycle of even training a foundation model, right? Except the pre-training stage, everything else is accessible by academia with modest resources, right? And even if you have a pre-trained model, introducing some reasoning capabilities in it, or introducing or fine-tuning it for particular purposes, curating it. So all of those, I think, can be done at a university. So that is something academia can do. And the other thing, I don't know if everyone agrees with me, I think the future is going to be agents. All of the important work is going to be done by agents. And these agents are not going to be incredibly big. But the agents will be orchestrated by a large foundation model. So it's almost like agents may be doing their own thing. They may be communicating with each other in their own language. But I believe foundation models is the way in which we will be able to interact with agents. So in that setting, again, there are many opportunities that building agents does not require scale. So anything that's a smaller scale, I think academia is well positioned to address. But yeah, in general, there are so many open questions. We can go on for a long time, but I'll stop there.
Yeah, thank you so much, Karthik. That is very great points. Yeah. Any other panelists want to share? Mm-hmm.
Yeah, weigh in. Yeah, so one of my jobs is a big part of my job is to come up with program ideas and try to sell them so that I can get money to give out. And one of the questions that we have to ask very concretely is, why should we do this? Is industry going to do this? And it's often a hard problem or a hard question, and hopefully sometimes answered by your comment, which is, if there's money to be made, industry probably will do it. So that means a lot of the problems we work on are not money-making problems. So that's one answer. But again, kind of back to my operational comment, usually because we are putting this technology in someone's hands or someone's life might depend on it, then our fault tolerances are quite high. So that in itself presents sort of kind of an additional area for research that I don't think industry, in some cases they do, of course, care, but in other cases they don't, close is good enough. And that is often not the case in the kind of research we do. So I do think there's opportunity there. And I agree with your comment about agents, and this has kind of come up lately on a program or concept we're working on, where we're looking at sort of teaming agents. And I think it's easy to see how maybe in some industrial use cases that would be helpful, but when we're trying to really understand kind of what we would consider kind of human interactions as applied to these agents, there's not really an industrial kind of motivation there. So I think there's lots of problems like that that exist that academia is well poised for.
Yeah, absolutely. That makes perfect sense. Thank you so much, Erica. Okay. Any other people want to share? Sure.
Yeah, I agree with almost everything has been said. I just wanted to share a few complementary thoughts. First, I wanted to say that I think there is already a lot of collaborations that are happening between industry and academia. I think industry is investing in a large number of research grants of all kinds that faculty get to apply. There is an increase in the number of interns going to academia, so interns going from academia to industry and back and forth, faculty. The difficult part for the question to me is the question of organic. Because as soon as there is any financial turmoil, I think all of those fundings can disappear very quickly. And we have seen parts of it, even with small turmoils. And so I just don't know how one can make that organic. It would be great to create some virtuous cycle, but there are many barriers to it. Some are economic, some pertain academic inflexibility to dual appointments, or there isn't a lot of people from industry that comes to teach to compensate for faculty that leave. So there are many other aspects of making it organic that I think are very difficult, and maybe there is not enough interest to make it happen. There are the same issues when it comes to, say, compute. There is a huge asymmetry between industry and academia, and the costs of, say, doing compute in AWS are still prohibitive for academics. Whether there could be partnerships of multiple universities getting resources from NVIDIA at cheaper prices. I think there are opportunities of things that could be done, but for some reason is not happening, I think. And potentially it's because it is more, academia is going to be a small buyer to NVIDIA relative to all of the other partners in any case. So I think it's going to be hard to make it organic, is I think what I'm trying to argue. Relative to the second question of competing or differentiating, the only disagreement with Al there is that I think, yes, in principle, academia aspires to do longer term research, but the practicality has been that all research in academia and industry is getting very close to each other. The fact that there are these conferences, academics are not after money, but they're after publishing the next paper that is now very quick turnout. So the ability of thinking long term is gone. The fact that grants in NSF don't last too long, if you were to give grants that are 5 years always, there would be more longer term thinking than giving grants that are 2 years. The same thing is true of DARPA with these phases that are very short and fast fused. So if the funding agencies want longer term research that is differentiated from academia, you also need to give long term funding, I think. And that's not happening.
5 years is 5 years.
Yes, and on these things also the sustainability of the long-term research. Someone said to me that the amount of money of an NSF grant per student has remained constant for the last 20 years. But if you look at the salaries of students and the fact that now they want bigger salaries because they can get better opportunities in industry, and the fact that they're unionizing, I think there is also something that funders should think about as to what is the actual cost of a student today, not 20 years ago, when they decide on the size of the grants and the length. Coming back to the compete or differentiate, I would like to push to the extreme position that industry has won when it comes to all of the research that pertains language and vision for most of the part. If we look at the last 10 years, I mean, what architecture or what great, fantastic paper that has gotten to the level of, came from academia? Okay, the theory papers, yes, but in terms of the architectures that have the highest impact, the one that's got, there's all industry at the end of the day. So the opportunity, I think, for academia is to differentiate, and that's where I agree 100% with Al, that AI for science is a big differentiator. AI in health, I think, is also a big differentiator. And therefore, I think we, in academia, we need to look for exactly for the areas where you don't make immediate money to be able to do long-term research. And the interesting thing is that, as was already articulated, all of the Gen AI problems within the sciences and within health are so much more challenging because of the scarcity of data, the diversity, the rare events, or and whatnot, right? And so they're scientifically perhaps more difficult. Let me stop there.
Yeah, thank you so much, Rene. These are very informative and valuable. I'm pretty sure this will bring a lot of thinking for the researchers in this room and definitely in the community. Yeah. Yeah, it's okay. Yeah.
Do I still have time?
Do we have enough time? Yeah.
I'll make it short. I'll just, I feel like I should discuss this because I can share some personal experience. So my background is, after I graduated, I joined Meta Fair as a research scientist, as like industrial researcher for 4 years, and then I, joined NYU just last year. So I've been in academia for 1.5 years, but I have been in industry for longer. I have to say, like, I don't regret the decision because it was really good working at Fair, like institutions like Fair, organizations like Fair, until it was not, just because of OpenAI changed the game. And to be honest, it's not fun anymore because I think, you don't want to just so essentially what happened is, basically, I think Meta or Facebook at that time faced a lot of pressure. And Rene mentioned that as well. And then they say, oh, like, let's stop doing this random explorations anymore. Let's do some, reorg, do this multiple times so people can work in the same team and work on some larger efforts. But the problem is, like, they don't have the culture. So at the end of the day, everybody's like doing meetings, discussing what to do as a big project, but nobody's really doing research anymore. So it's like terrible times. That's why a lot of myself and a lot of my colleagues, like Kaiming and Georgia, we all left and we went back to academia. I think it's quite fun because it's indeed a lot of freedom, and it's indeed, at least my personal feelings, like I can take more risks. I can do something that's longer term. And I'm not working on AI for science right now. I'm still working on like core vision problems. But even in this kind of like very competitive thing and this kind of like pretty crowded field, I still feel like we can actually, in academia, differentiate ourselves from other industry works. And to be honest, like they are very risk conservative, their risk tolerance is pretty low at this moment. This is why a lot of like vision researchers cannot really do vision anymore. They need to switch to do large language models because this will bring them the immediate benefit. And this is also why I actually feel like now is a good time to do something like computer vision because, again, language model is so dominating, but we're actually not solving the problem, many of the problems in sensory modeling. And of course, in terms of like collaboration, I'm also collaborating with Google. I'm actually having a kind of like 20% role at Google right now. I think I haven't really told them, but my main motivation is to be able to know what they're working on and avoid working on something like that in academia. That worked out pretty well. So I think, but I think this should be more, organic, as Rene just mentioned. I think company also has the incentive to, try to make some bets in some domains. Like they probably don't have the headcount or the money to spend on these topics, but I think a lot of the researchers in the industry, they are pretty happy to see new possibilities. So I think there are actually a lot of good opportunities. The problem is like it's indeed really hard to make it organic. Like for example, in our relatively large scale foundation model training, this Cambrian 1 model, we used multiple clusters at NYU. We use some AWS credit. We use like Google TPU. We work with at least 3 different code bases with PyTorch and JAX. each of my students, I feel like they are doing like maybe 3 full-time jobs compared to kind of industry researcher. But somehow like we can make it, but it's like not a very nice experience. I really hope like, in the future, with the help of, like a government agency, funding agency, companies and academia can coming together, we can actually build this more organic community, sharing some of the tools at least to make something, to make this effort more like accessible and easier. I think that'll bring a lot of benefit for everyone. Yeah, I'll stop here. No, thank you.
Yeah, thank you so much, Saining. It's great to hear you sharing your personal experience and defining what you are thinking about, how to handle this transfer from the industry back to academia. We definitely have seen quite a few examples in the recent years, and I totally agree with you and also all the other panelists to share. Like, it's hard, it's challenging to have the organic community, but that is the reason we're discussing it today, because we're envisioning what we can do in the future, paying our efforts and time on that. I really appreciate all of you share your great points and inside views. So for the time interest, I think we're close to the ending. Just want to see if there is any question from the audience to get the final opportunities that can, share the thoughts and also like discuss here with our pretty great analyst. Yes.
Hi, Sandy. I have a question for the last question you have mentioned. So given that currently in the academia, the computational resource can be quite limited, and for example, training the model architecture like DIT or SIP requires hundreds of GPUs. And what do you think like the academia should pursue like in this kind of scenario? Like, is there any other task? Because academia we don't have those many graphical cards. Like, is there any other better task that we can focus on, like in parallel with the like training foundation models, like what you did in the industry?
Yeah, let me just repeat the question for the people on the room. So the audience is asking like, it's also, I think it's kind of like follow the second question. So in a specific situation, with this kind of limitations of the computational resource, and also what Saining just shared, it may not be a very good experience to train such kind of large-scale foundation models in the academia. What kind of specific tasks that you think will be interesting, will be valuable for us to look into in the future years regarding for this kind of the academia uniqueness and also opportunities? Yeah, I think that could be the question for all the panelists who want to take that.
AI for science. That's definitely one option. But if you really like into like vision and other mainstream tasks, find your own way. In a sense, like when I was doing my PhD, like our kind of GPUs are much worse. So I work on like much smaller scale kind of problems. But nowadays, well, already like even with kind of academia resources, we won't be able to train kind of billion scale kind of parameter models, but we can still explore something that's very unique, very different, and we can still train a reasonable size of models, right? And the lesson scaling law is telling us, as long as you are not just working with toy problem setups and with toy models, there's a chance you can actually find something meaningful, and maybe this will be picked up by industry researchers. They can help you to scale up and generate kind of impact. But again, like this is really case by case. My suggestion is like don't be afraid, and if you really have a wonderful idea, just to find a way to do it. Yeah, and I think this type of way exists. Yeah, thank you.
Cool, definitely, totally agree. Yeah. Any other panelists who want to add anything?
I just want to say, outside of pre-training, which is probably a bad idea to do in academia, I think there are so many interesting things we can do with very modest resources. I actually think everyone with a laptop can fine-tune a reasonable size model in the coming years. So yeah, there's many other things outside of pre-training that we can do with modest resources.
Yeah, for sure. I think that's definitely possible if we look back to the first neural network on the ImageNet, right? On this kind of vision problems, and compared to what we can train like the ImageNet within how limited resources in the time and memories. yeah, that is what's happening in just a few years. So who knows what will happen?
Can I add one more thing? People are scaling post-training algorithm as well. People are scaling agent as well. But still, I think at this point, I completely agree. Like, work on like new things, and then ask other people to scale it.
You can build on big things.
Yeah, definitely. Cool. Yeah, I think we're almost at the ending. And also, without further ado, I want to thank you again for all our great panelists to share us your unique thoughts, insightful opinions, and also to share this kind of the discussion, answering the questions. Really appreciate that. And with this, I think we will end the symposium today. And thank you so much, everybody, for coming here in person or either on the room. Yeah, hopefully we could have the chance to host that next year, but it's not guaranteed. Yeah, so we'll see. Yeah, thank you so much. Have a good weekend.
So I'm working with the Center for AI Safety on the BioJet program. Yeah, so I'd love to talk to you more about it.